here MAF. And we're going to see we have a couple different choices. We're going to bring all of these in. The crank MAF table here is going to be what we use, and I talked about this before, what we actually use for our starting, for the air mass registration when we're starting this engine. So let's go ahead and scrunch this up here. I'm going to give it some color. We can see it's based on throttle, based on engine RPM, and it's based on the values in here. So we're going to do two things. We're going to right click here. We are going to go into, let's go into our number format options. We're going to make these 2 decimal places instead of 1. We can see right now it's just 0.2, but that doesn't give us enough information of what's going on there. Let's make it 2 decimal places. Let's apply it here to our table. We'll click this box and then we'll go OK. So we can see I've expanded our decimal place out. It's a little bit easier to see what's going on with this. Let's also give it some color. So we're going to go here, right click, color options, and let's jump in here. Let's change our colors. Let's go to our gradient 4. I like to use that one. And we'll put in some values here. So we'll go from 0 to, let's go here to 0.1, and then 0.2, and then 0.3. Now, this table has very low values in here, and the unit's going to be in grams per rev. So this is going to be directly related to our injector pulse width. Very small changes here will have a pretty large pronounced effect on the injector pulse width. Kind of similar to that cranking VE table that is now absent. This is now taking the place of it. So let's go here and click OK. We can see it's got some color. Now the way this table works here, we can see at 90% throttle, the table's zeroed out. So if you're flooding the engine out in the way this table's set up here, if you give it all the way, go full throttle, essentially here at 90% throttle, it's going to be shutting down the injector pulse width. It's going to be clearing it out. So if we have a really low value here, it's going to be scaling injector pulse width down. If we need more fuel, we're going to go up here in injector pulse width, and that's why it varies here with throttle angle. If we give it a little bit more throttle, we're going to be essentially adding more air mass or introducing more air into the engine, and then we need to have a little bit more fuel in correspondence. So we'll take a look at this and play around with it a little bit. Normally you don't have to adjust it here for a stock setup. It should fire up the engine pretty well because this is a base session, but we'll see if we need some adjustments. Let's do the same thing again here. Let's go right click, let's go to 2D table. I'll be typing in here MAF again. Let's take a look at our MAF filter table. Now the MAF filter table is needed as we're revving the engine on a mass airflow equipped car. If we ingest too much air, this is going to be biasing it, and it's going to be scaling down essentially what would be the equivalent of the acceleration enrichment. It's going to be calming things down a little bit. So we may have to adjust the values in here. Let's go and right click. Let's do the same thing. Number format options. Let's do our precision as 2, so we'll do 2 decimal places. We'll apply it to the table. We can see it expands it out. Let's right click. Let's go into color options. We'll go here to gradient 4. Click OK. And then the numbers in the table here from 0 to 1.0. It's going to be the filtration amount. So I'm going to go here from 0. I'll go here to 0.2, then 0.5, and then 1.0. And click. We're going to apply it to the table. Click OK. So it has some color in there in the table. Let's go and right click here. Let's go into our 2D table. And we'll type in here MAF failed. So if we're using a MAF failed mode, there is that option. We did not click it. This would be the table that would allow it to have some kind of a backup value so that the engine would continue to run. In this situation, I'd rather have the engine just shut right down if it had some kind of a problem. So I wasn't going to be using that, but this table is here and it is able to be edited if you choose to do so. I'm just going to add it to the template here just to get it out of the way so we have it available. I'm going to go here and right click on the top bar here. Right click, go here to color options, and I'm going to be changing this to my colors. We'll go gradient 4, click OK. Now the numbers in here can go all the way up to 20 or 30. That's going to be really high, but we can go that high here. So we'll go all the way from 0.1. Let's go here to value of 2. Let's go to the next one here, value of something like 4, and then 8 on the top end. Make that red. Click OK. So add that in there, has some color. Now the next thing we're going to add here is going to be a 1D table. And if we type in MAF here, we're going to be looking at our mass airflow curve 1. We only have 1 mass airflow sensor on this. Now if we have some other applications, we might have 2 mass airflow sensors, but this case only has 1. This is going to be the calibration scale in grams per second. This is going to be where we do our actual fuel tuning. It's super simple, as you're going to be finding out, but this is going to be a lookup. So it's going to have a particular voltage value for this mass airflow sensor type. It's a 0 to 5 volt. At a particular voltage, it's going to be looking up what the air mass is going to be coming in the engine. So that's going to be the beauty of the mass airflow sensor. We have to do our job and recalibrate it, but once we recalibrate it, it's going to be very, very accurate. And as our air density changes, if we have our air temp changes or our barometric pressure changes going up or down in elevation, our mass airflow sensor will directly compensate for that because it's registering or measuring our actual air mass. We're not calculating it based on a map sensor and then a baro sensor